Hello everyone. So in this tutorial, we're going to be taking a look at AI chatbots inside of Unity. If you have a project and you'd like to have an AI controlled character inside of this, we're going to be going through the whole process today. From setting up an environment in Azure to getting your 3D model connected to it and being able to talk to your AI character and have it respond back to you inside of a Unity environment. So without further ado, let's take a look at what we'll be creating today. So over here you see a project that I've already been working on, and it'll be kind of the end result of the tutorial that we're going to be doing today. If I get it started, you see here the 3D character that I've created, and I've made a little knowledge base for it, and we'll be able to start speaking to it. So, hello there chatbot, how are you doing?
Hello everyone, I'm excited to kick off this amazing tutorial with you. Let's dive in and discover some fantastic insights together. So make sure to keep watching, it's going to be great.
Fantastic insights. Alright, so let's get started. To get started, we of course need an Unity project. So I made one in Unity 6, it's completely empty still, so let's open this one. There we go. Alright, so first things we need are a couple of packages that are required if we're going to be importing assets and getting everything set up properly. So let's go through those ones first. So if you open up the package manager, you'll be able to add some custom packages here, and it's very easy. If you go to the plus icon here, and you can install packages by name, which is what we're going to be doing. So first one is a package that we need to be able to import GLB files, which are kind of like 3D models, but a little bit different. And it's called Unity GLTF Fast. And as soon as that's ready, all right, one more package that we're going to be needing is this one. And it's the way that I'd like to handle my JSON files. So install that one as well. Alright, so that one is installed too. So since we're using Azure to make our AI chatbot, we need to have it connect to our Unity project. Azure luckily provides some samples for this. I'll be sharing all of the URLs inside of the YouTube description. And we need to go to the Cognitive Services Speech SDK. And inside of here, you have a folder called Quick Start. And this one goes through to C#, to Unity. And then we need the text-to-speech one. So here you see a little README going through all of the setup steps. And also it provides us with the actual SDK, which is a Unity package. Download it from here. And as soon as it's downloaded, we're going on to the next step and actually importing this. We can open it up and import the Unity package. What you'll be getting as soon as you install the package is that it relies on another package called Azure Core. Now this package is not installable through the package manager, but you actually need a separate package manager for this called NuGet. And this can be done with the following resource, NuGet for Unity. So you can go to this URL and actually install NuGet for Unity. Easiest for me was to actually just install it through the package manager. Going here, you can see the package manager again and install it from a Git URL, because this is a Git URL, and hit this. It'll install the actual manager for all of these separate packages. As soon as this is ready, all right, looks like it worked. So if you go to NuGet, you can manage your NuGet packages. It'll open up this new tab for you, and I'll just dock it here. And we'll be looking for azure.core. So if I type in azure.core, there you go. this is the one we need. So hit it, install. It'll be compiling. All right, and that's it for all of our base packages. All right, so let's head over to our LLM of choice. For me, it's ChatGPT, at least for today. And the question now is, what type of character do we actually want to create for our game? So I had this idea of maybe doing like a simulator of working in a restaurant as a waiter and having like several different customers you can talk to. Maybe some of them were also difficult questions and you have to respond to this and maybe see how well you can manage. So things to think about are like, what's the age of this person, or the gender, the ethnicity, the hairstyle, stuff like this that we actually need to visualize this character, but also the backstory to make the whole simulation a bit more believable. So if we just start out by asking ChatGPT to write us a backstory of a difficult customer that I might encounter working at a restaurant as a waiter. Now, this is what LLMs are particularly good at. Now it all really has a name, an age, a backstory, stuff like this. And this will all work. This will all help us writing the prompt a bit better. Now we actually want to have a visual description. All right, well, that sounds good to me. This actual description is what we'll need to generate our portrait images. So for this, I like to use Dream Studio, and going to this, we can actually generate some images. And I just like the interface here, but you can also use whatever you like. So we need to enter in a prompt, and this prompt is what we already have. So the visual description, we can ask it to write it shorter, please. All right, that works. And now we ask the image generator to, I've already done like a couple of these ones earlier, generate us a close fisheye selfie photo of this person. So just have this as a suffix and then paste in the rest and let him just generate. There's a lot of like distinguishing features here. I think this is the best one. It's like close up and it's also like relatively symmetrical, at least from a good angle. So if I download this one, we can use it and actually generate the multiple angles of his face. To get these different angles, there are a couple of options that we can try. So the one that I've tried before is called Reshot AI, and this one is, I think, the most solid one. You can actually position the face like this, and I think it does cost like $10 a month or something. So this is also an option. Expression Editor AI, same problem here. It also costs you something. Also pretty solid results here. But today we're just doing like a little test. So I'm going with the free option. On Hugging Face, you have a space called this face poke. And if I upload the image here again, just a fresh one, you see this is the original, I think. And you can click here around and actually the guy will look to the left and to the right. And these are the images that we actually need. So I'll download this one and I'll download maybe this one. we'll need to actually make this into a JPEG. So go to downloads, get your WebP and your other WebP, and on PhotoPay you can actually just export it as a JPEG. Export this one as well as a JPEG. There we go. And now for the part to make this into a 3D character. So the thing that I really like to use here is Avaturn. It's pretty solid when it comes to making a 3D character that you can animate and also has facial animations. Really like this. If you create a new character, you can do this with your own camera, going to the QR code and actually make photos of any person, like yourself. So this is supposed to be me, I guess. But also it has the option of actually uploading these, and this is what we need the photos for. Now we have to pick our gender, which is a man in this case, and we have to select the type of face that we want. So this is the more lightweight one, it says, but also it has static face, so we want the version 2. And version 2 we can actually animate the face using the Blendshapes. If I hit submit, it'll go start uploading photos and generating the avatar. Alright, so we have an avatar that's being created. Now this product Avaturn, it's not the best at making older people. It just does a couple of presets. You can probably already tell the guy has some wrinkles, but it's not the prettiest looking. But we can help it a little bit if we just change like stuff like the eye color and have it a different body type, give it some hair that's more fitting. Now you can like go into the texture and like get all of the things out that are not supposed to be there. But still, in general, I think if you look at the first image and compare it, you can kind of see the resemblance. So that's the idea. Maybe he has like glasses on, he has like some cooler shoes, or like more shoes that you would wear going to a restaurant, I guess. And you can also see like the animations. So it's already like rigged and animated. Some superhero poses. Alright. Now you can download this model with the animations over here. And these are just the T-poses and the body only, but we actually need the one with the animation. Not because we actually need the animation, but this has the blend shapes in there. So that's what we actually need. And it's in GLB format. So this is the reason why we actually needed the GLT fast package to be able to import these models inside of Unity. So going back to Unity, we can import this model. Over here, drag it in and drag it in our scene. So we're running a URP project, so this is basically what it looks like inside of Unity. Now it already has an animator on there, but I guess we need to create a new actual animator controller. Doesn't matter what you call it, like model animator controller over here. Just assign it, and inside of here there should be an animation that came with the actual model. And if we drag it in here, this is going to be the default state. And yeah, it looks already. So going back to the game view, let's get this character rotated for us and have the camera be a bit more up close so we can actually see what's going on. There we go. I'll change this to solid color, make it a bit more clear what's happening. Save the scene, and let's see what character is looking like. All right, so now that we have the character inside of Unity, generated with like almost no effort, just getting it set up and even like the concept done with AI. Now any step here that you want to do yourself is obviously it can work. Now that we have the character just kind of statically like looking around, we actually want to be able to talk to this character. So that's going to be our next step, getting our Azure environment set up. Now heading over to Azure, we're actually using two separate Azure services. So one is the OpenAI service that actually does the chatbot feature. So you can send prompts and it will like generate a response like an LLM. And the other feature is the speech services. And that does the part of interpreting our voice and making a text-based out of this. And also in the reverse end, it'll make the response that we get from this OpenAI service and generate like a voice back from this. So what we need inside of Microsoft Azure are these two keys to these two different services. Doing this, we can go to services here, and if you go to like AI and machine learning, you'll find speech services here. Go into this one, and I already made a default one for myself, but if we go to the, I can show you how to create a new one. Pick a subscription that you're already running, and I'm just using a free one. I think like default is already free for me. So pick the most local region that you are in. Just call this tutorial speech for now. Pricing tier, standards, and I can actually create this one. All right, default looks good to me. And over here you should have, as soon as this deployment is ready, you should be able to go to your actual key. Let's see where it is. I can go back here, and it should be somewhere inside of here. So tutorial speech. And over here you can manage keys. And my keys, like I can copy it to clipboard here. This will be needed later on inside of the tutorial, but for now, I'll just go back to the main portal, like to my dashboard, and now look for the OpenAI service. So back again to AI and machine learning. There is your Azure OpenAI, and you want to be creating one of these as well. So I can create a new one, show you guys how that's done. Kind of similar to the previous one. You select like a resource group, and for me it is Western Europe. Tutorial AI pricing tier, stuff like this. Network, configure network security, all networks. You should include all networks so you can actually access this resource. Tags, not needed for now. And I can create this one as well. All right, deployment complete. So check out the resource. And it's over here, tutorial AI. And in the same way that we have this previous resource, there's also endpoints here and the keys to manage. Key one, this is what we're going to be using later on in the tutorial. But just to make sure that it's all set up, these are all the resources that you actually need. And now we can go ahead and actually start coding. So in order for us to know what will be needed to actually do this whole flow of talking and receiving answers, I thought it would be important to show you guys the actual flow of what's happening. So inside of Unity, we'll be doing like some voice input. We'll be talking to our microphone. The microphone will be picked up and then generating audio clips, or an audio stream in this case. And we'll be sending this to the Microsoft Speech Service, which we created. So this is actually the Azure Speech Service. Inside of Unity, we'll be calling it Microsoft Speech Service. This will be doing our speech to text. So in order for the LLM to do any response, you need to be sending it actual text messages. So our speech will be translated into like text, and it'll create a string, and this will be going into our LLM, and it'll generate like a response for us, also in text format. We could be translating it back into speech, or like synthesized speech, and this audio clip will be played inside Unity, and this will be done together with the Blendshapes that we also will be playing on our AI avatar. And this is something that Azure does. It generates our VSM Blendshapes. This is very interesting process as well. A VSM is basically a shape that your face can take, and it will be going through like every word has different shapes that are corresponding to this word. And the nice thing about Azure is that it doesn't just generate these VSMs. This is something that other types of services do as well, but Azure actually does the Blendshapes for us, which makes it a lot easier. Blendshapes that also work with the avatar models. If you go into your model, you see the armature, and the head mesh already has a list of Blendshapes that are present. So if I actually zoom in here, you can like do like a tongue out or like a mouth funnel. You see the actual shape of the mouth change, and this is what Azure is already exporting, like a whole list of Blendshapes based on the time that it takes. So this makes it a lot easier for us. So looking at what we wanted to do first, the way I would approach it is actually looking at the flow of the whole game. First thing that we want to have working is the voice input, and actually generating an audio clip that goes to the speech to text. So where this happens is mostly inside of this class that we'll be creating. So if we go to our projects, I'll create a new scripts folder to get all our scripts in there, and create our first script. Call it Microsoft Speech Service. There we go. Open it up. So this doesn't need to be a model behavior, it doesn't need to be inside of our scene, because it just does like the basic execution of APIs and stuff like this. So we'll be creating one during runtime. But there's a couple things that we actually need to recognize this speech. And the first will be like a speech recognizer. And basically where I got all this is in documentation that's available. So over here, like on Microsoft, there's already all of these documentation things here. So taking bits and pieces from here is usually how I would do it if I weren't watching a tutorial like this one. So we need a couple things here, like a config, and using this config we can create like a speech recognizer, and then basically as soon as it recognizes any audio coming in, it tries to like decipher anything that the user has said, and as soon as it recognizes it, then it can print it out, and whatever the result is, you can do something with that text, like you have the audio converted to a string format in that case. So if I open this up again, we can make like a recognizer, make like get private set for it, like pretty default everything, and we need like a speech config for it as well. that just has like all of the configuration related to this recognizer. So we can make like a public Microsoft speech service that you can call, and yeah, just set the basic stuff. So inside of the speech config, if you see this here, we can say like, okay, get it from a subscription, and this is like the key that you need for the speech, like your speech service, and it's like the region that your service is located in. So if we go back to Azure, this would be over here, the tutorial speech service key, and then also the region. Now, what I would like to do usually is have all of these settings like more easy to recognize, and be able to change this inside of the editor as well. So I would create like a, how would we call this, like a speech service config, I guess, and make this a scriptable object like this. And then you can basically say like, take out the namespace, like not really needed in a project as small as this one. Do something like this, say like, okay, file name, and have a place where you can actually create this scriptable object. Now I already made one before, and I'll just copy and paste over the actual data that we need for this project. So we need an OpenAI endpoint. This is where we're going to be making the calls to the chatbot itself. The region for me is West Europe by default, but you can change it inside of the editor. Now this is the speech key, the speech services key, and this is the OpenAI key. And later on we can select a voice that we want to have the chatbot to have, and also a system prompt. So this is the background information that the chatbot already knows before we even start speaking to it. Going back to the projects, with this compiled, we can create one of these configs. Over here, you will see speech service config, and over here you can just insert all of your data. Go back to your customer backstory and say like, okay, generate a prompt for me that can be used by a chatbot for this person or that character. There we go. So you can give this as background information. And keep it short, because the more actual like characters that you use, the more time it'll take for a response to be generated. This is short enough. You can make it like twice as big as this, but not like like pages and pages, because that will be too much for the chatbot usually. Last thing that's interesting here is you can actually pick a voice, and there's a voice gallery that Azure has as well. You can try out a couple different voices. Go to speech.microsoft.com, and over here there's a voice gallery, and you can try all of these different voices and just listen to them.
The Unemployment Insurance Fund.
Okay, so a different one, and then just pick whatever fits. And over here there's some sample codes, and if you open this, you can see, okay, there it is. Oh, this is horrible. Alright. You can say like, oh yeah, this is the voice name, so pick this one, and we can drop it inside of here. So now it's a different voice. It's like multilingual. Should be good. Maybe it sounds a bit too young, but Alright, so everything here set up. That's great. Now we can go back to the setting this up for ourselves. And it would probably be good to pass in that config here as well. So we'll need like a private speech service config, and call it like service config. And every time that we make one of these, we would probably pass in one of these configs. And just say like, oh yeah, speech, or like service config gets service config, just initialize it. And now we have access to the data that's in here, so we say like service config dot speech key, it's what we need, and also for the region, config dot region, there we go. Pretty easy to set up. And now inside of speech config, we can also set the voice, called like synthesis voice name, that's the one, which we can now pick a nice voice and change it in the editor. Alright, next step is setting the recognizer, the thing that we actually wanted to do. So here we actually need like an audio input, like picking the actual input of the audio stream that we're trying to listen to. And there's like an audio config class inside of the speech services. And we can just pick the microphone inputs, or like the default microphone inputs. And this is the one that you would have set, for instance, in your system settings, or probably easier to go through it here, like in your sound settings. And here you can pick like an input device, and on Windows it will be something similar to this. Now for the recognizer, we can initialize it too, like setting the new speech recognizer. And here we pass in our speech config, and also the inputs that we want to have it listen to, so like this. And now I'll just copy and paste what was there on the website already. We can listen to when it's cancelled, or when the session stops, we can just log it, like, okay, give us a reason why it's cancelled. And the thing that we actually want is to have it actually listen to the recognized, and just give it a method here. And then anytime the speech is recognized, it gives us the event, like the arguments for it. So you can say like results dot text, and this will be our recognized text, like this. So we initialize this speech service, and with it we initialize the recognizer, and the recognizer, as soon as it recognizes anything from the audio stream, it'll call this, and this will just, for now, maybe we should like print out the text that it recognizes here, for instance. Now the next step would be actually doing something with this text, so sending this text to our chatbot. So I'll create a new script, Unity script, specific AI chatbots. This will be the place for the logic relating to our actual chatbots. Alright, so the thing that we would need here as well is one of these speech service configs, because it has all the relevant information that we just passed in there. It's nice to have this inside of the project, or inside of the chatbot as well. Probably need to serialize this as well, so we can actually assign it in the editor. And on awake, we'll just do some basic setup, like initialize the service. So this will be the place where we actually use one of these Microsoft speech services, like this, and try to do like new, and then remember that we needed to pass in this this config. And now that it's ready, we can even use this speech service recognizer and put some logic when it recognizes something, or create a method when it recognizes it. Like on recognized. There we go. And as soon as we have a result, we can also just check if the result is not how'd you call it? Like if the reason is, there's a lot of reasons that it could have recognized something, but we're actually looking for that the text is being recognized, just to make sure it's not firing when we don't want it to. So recog like a result reason not recognized, and I think we need to have speech here. Alright, so now we have this result with the text based on the speech that's being recognized at the moment. But as soon as it recognizes the speech, we want to actually send this text to our OpenAI chatbot. So if you go to the documentation from OpenAI, you can see that you can get a response from OpenAI, and you specify a model, and we're doing that by setting our OpenAI endpoint somewhere. And then the input that it wants is needs to be formatted roughly like this. So we define a role. That could be like the system. So this will be our system prompt. It says like, oh, this is the background information that you need. And then later on we can send like things that have been set by our user. So this would be, for instance, the thing that's over here. So this would be our system prompt. And then the text is actually the text that's being recognized. So that would be this text over here. So let's just start setting up this system for us to recognize this text. So it needs to be like an async function here, and let's just call it generate response from texts, and it's async, just to be sure. We can send in the text that we have, and also perform like an action with the string that it got back when it's successful. So I'll call it like on success. Alright, there we go. We basically say, okay, let's just set up our actual request that we're going to be making to the chatbot. So as you've seen, it expects something like this. So just to get that quickly set up properly, I'd usually like to say like a data types folder, and for this one it expects a message type, so let's just like call it message, and this can be a lot cleaner, but I've set one up already. So it's called message, and you have like a role and a content similar to what you just saw, and you can set it up like this. And inside of our assistant, we can set, or like our chatbot, we can set create like a new list of these, a list of messages, and just add one of these messages to it, and The message in this case is a new message by the user, because the user is sending this, and then the content is the prompts that we're sending with it. And then we can make this a JSON format. So like JSON payload that we actually are sending gets a JSON convert. Alright, and we can serialize this object messages over here. And then actually send this. So we can say like, okay, we want to have a response. And this response we can like await our speech service, and then have the speech service actually get our response for us. So we send in this JSON payload with it. Alright, let's go to speech service and actually set this up. Alright, so what we did here is actually build the request that we're trying to send. And this is basically how OpenAI expects calls to be made. So sending a prompt of messages that you want to send, and then having like the max tokens, just to make sure you're not going over budget. HTTP client is done to do like networking inside of Unity. And request headers are basically additional metadata that you send with your request. And it expects us to have an API key, of course. So we send one of these API keys. And as soon as all of that is ready, we can actually send the content asynchronously over the HTTP client and await response. And as soon as we have this response, we unpack the response. So we get the content and just read it as a string. And this string is packed up in such a way that we have the chat response, and it has like a list of choices, or like these are like choices you can make. And inside of this, there's like a message, and inside of the message, there's actually the content. So I didn't make this up, it's just the way that JSON is packed, and this is what it expects you to like deserialize it as. So as soon as we have this, like pick the first choice, because you sometimes have like multiple choices to pick in one of the chat windows, but we never do that here. So you just get the message and then get the content out of this. So if we go back to the response, this is actually the response that we get. And as soon as we have this response, then we can go on with actually returning the response, because we're returning a string over here. So we send the text in here, and we have the response ready. And if this is actually successful, we can invoke the success action with the text that we have. Alright, now that we have the response from the chatbot, is still in a string format, so we basically want to make this into an audio clip. So if we say like generate audio clip, we can pass in the response response here, and this will be the clip that we generate inside the speech service. We can actually synthesize this text, and this is also contained inside of the SDK, and it expects one of these speech configs that we've already been setting up, and then also the audio config that we just set up here above. And as soon as that is ready, we can build a request. And requests are made inside of a standard called SSML over here. And this is basically the way that we choose, like the way that we say how we want the speech to be generated based on the inputs that we send. So there's a lot of like things that you can specify, like the language, the voice, but even like the way that it talks back to you. So you can have a lot of stuff that you can change here. Maybe there's like a introduction. Yeah, over here you can say like, oh yeah, it should take a long time, or it should have like pauses in between, or there's a lot of stuff you can change. But for us, we're just doing like a pretty simple one. So SSML request, and we can basically just build a new one. So we pick a version of the actual standard, like the version of the SSML, and then we specify the voice name inside of here, and also the fact that we want, this is the reason we're actually using SSML, but we want a certain type of VSEMs, so we want the facial expressions, and this is what is actually allowing us to return the blend shapes, and this is what we use to animate our face. So now it has all of the information, including the metadata that it wants. And we can actually return the speech. So the speech result is also done inside of like one of these audio streams. So if we say like processing task, and return one of these audio data streams, we can handle the speech output, or like the speech results, and this is actually the result that we want. So the speech synthesis. It's a difficult word. Results. And we can just basically check for any errors here. So if the result, the reason the result came back is the reason that it actually the audio is synthesized completely, we return the audio data stream from results. And we can also check for like do some error handling here if it's a different reason, and return like null after handling the error. Alright, so now we have this clip, this data stream, like this void that I connect this async first. So we now have this this clip or this data stream, and we can actually play it now, or like make it into an audio clip. So going back to the flowchart that I showed you starting out the video, we've been handling the voice input now, going speech to text, and sending this to Azure. There's something that we need to do before we can actually test the responses from Azure, but we've already set up something to handle the string going back from text and then actually making it inside of the speech synthesizer, making it speech into an audio clip is something that we are looking at next as well. So if you go to your Azure page, like your dashboard again, you can go to OpenAI and you see this. These are the resources that you have. And you can actually go to the AI page of Azure. Looks a little bit different, but over here you can set deployments. So these are like AI models that you can choose between. And I'd recommend going for a mini model. So like O4 mini is way quicker. That's like chat completion. This is actually what we are looking for here. I don't have any quota left, but I do have a separate one that I already made before. And it'll just give you something like this. And over here you can actually already test some of your chatbot without any Unity implementation yet. So if I go back to Unity, I can select the system prompt just to test it out. This is the instructions that you give to your chatbot, and then as soon as you say like hello, it responds by asking us for the menu, of course, because he's still waiting for his dinner. Over here you can see your deployments, and if you go into your actual info about the deployments, it has this target URL, and this is actually what we need because we made a custom one. This is what we need to send our API calls to. So this is actually the actual endpoint that we need to set. I think it's time to start animating our character now, because we have this data stream, we want to have some audio playing, but also have our character actually animating as soon as the speech comes rolling in. Okay, so what we are going to be putting our Blendshapes on has to be a skin mesh renderer, like this. Skin mesh renderer. We of course need an audio source to play these sounds on, so that should be just a audio source. And we should keep track of our blend shapes, because we get a list of blend shapes in a queue. So I'm just making a list of because a blend shape is a list of floats. So it's a list of floats, and we can call this like the blend shape queue, because it's queuing all of these blend shapes to be played. Let's make a new one. Alright, so this audio clip that we want to be creating is not a clip yet. It's basically an audio stream, like audio data stream still. And for us to be able to play it, we still need to make an audio clip out of it. We can keep track of any time that we recognize that a new audio stream is available, because it's still running in async, and if it's running in the background we cannot generate a new audio clip, so we're running it in the update loop instead. Over here we can make the audio clip from the audio stream to be able to actually play it. So we go to our audio source and set the clip to what we are trying to create, which is the clip. For this, I suggest making a new class, call it audio helper in this case. And this is something that I copy pasted off the internet because it's very straightforward, but it is really annoying if you want to do it yourself. So it basically gets this audio stream and then takes care of all the sample rates in general and all the memory management here. Basically what it does, it creates like this audio clip that we can use inside of our chatbot animator. So if we go to audio helper class dot convert and we put in this latest audio data stream, we actually set the clip for it. And now it's just a question of playing it, and that's basically what we do to play the audio. Now the last major part is getting the Blendshapes set up. So every time the chatbot gives a response back, the speech service is able to take that response and make like animations based on the text that it receives back, and also based on the voice that you've selected, because different voices have different ways of articulating. So if we go to the documentation of our SDK that we're using, so it's this one, we can also see the facial animations that it gets. And over here you see different text to speech, it's different VSMs, and you can see all of the flow here, very useful. But here you can see what VSMs actually are. So silence is just mouth closed, and then you have these different vowels and stuff that you can use. And this you would need to map to specific Blendshapes yourself, which is more work, and mainly done for like 2D character animations or like cartoon animations, I mean. But the 3D ones that we want to be using are way more useful because we can set Blendshapes. It has a frame index and then also a Blendshape corresponding to that frame, because every frame is like a different frame of mouth movements. Now this is something that has been set up like this, because there's 55 different Blendshapes that it does, and it has this specific order. Now if we go to our own project, we can go back to our head mesh and see that it's not in the same order that we have as it is here, because eye blink is the first one, eye blink left and with mouth open here. So we need to map this ourselves, and I've already done that manually myself. So if we go create a new data type and call it like Blendshape mapping, I've set this up myself, and this is available as well for you to copy paste. So this just corresponds to the same order, and I just copy pasted it because we need to actually be able to look up the name of the Blendshape and then map it to the correct Blendshape inside of our skin trash renderer, because the names are the same but the order is just different. Alright, and if you saw correctly here, the way that it responds is with a frame index and then Blendshapes. So we recreate this JSON object the same way we just did for the responses that we got. So I'll just quickly do that. So we have a list of floats, and a Blendshape is just a list of floats. So if you see here, it's a list or array in this case of floats. So if we look back at our synthesizer again, so this is the location that the text is actually being synthesized and generated. We have this very useful event called VSMs received, and if we make a method for this one, we say like on or like handle VSM received, and this argument here we can get the actual Blendshapes from it. So if we say animation, because it gives us back an animation, we can get the blend shapes out of this. So we can get the frames with the blend shapes. So we do a JSON convert again because it's still serialized, but if we deserialize the object and make sure that it's frame data, so I do it correctly, and get the animation, then we have the frames. So we can go to our chatbots. Probably want to include the chatbot here as well. AI chatbots, and if we start this, we want to pass along the AI chatbots. Keep it easy. Go back here. Chatbot, and then we basically want to return these, or like give these frames to the chatbot so that we can actually queue all of these animations. So okay, so now what it does is anytime that we have recognized that the speech is being generated, just close these, we handle the received VSMs, or like the received blend shapes, deserialize the blend shapes into frame data, which is set up like this because this is what we get back in JSON format, and queue the frame data, and frame data we can just take the blend shapes out, queue the frames inside of the blend shape queue that we have here, and now we should play these blend shapes. Alright, now that that's done, I can tell you what's actually happening. So in later date we are checking if there's new frames inside of the queue, and if there are new frames, and we've set that it's actually queued and it's ready to go. We check on the current frame, and this is done to just manually make sure that there's no frame drops or anything. We just set the timer and set the current frame to the next one, making sure that we stick to the frame rate of 60 FPS and not go over or under or anything. And if there's a new frame to be played, then we actually update the blend shapes. And inside of this is where the interesting stuff happens, because we go through the queue and take the current frame, and then we go through all of these blend shapes, all of these floats that are inside of the list, and we check the name of the blend shapes. So based on the position that the blend shapes are at inside the skin mesh renderer, and this is what we actually needed the blend shape mapping for. So now that we actually have the integer, or like the index of the blend shape in question, we can go and get the actual name, and with the name we can actually set the weight. So here we actually setting the blend shape, and when that's done we reset the animation and set all of the blend shapes back to 0. Going back to Unity, we can connect all of the separate parts together, and going to the model, I'll just add this chatbot animator that we have. It needs an audio source to be able to talk to us, and make sure we set this correctly. The blend shape that we want to be modifying is inside of the head, and we can make like a new, I call this like AI surface, and we need the AI chatbots reference the animator here, and also have this speech config. So that's this one. So it has all the correct information. Alright, if you're running on Mac, you probably get this security message. And you can go to System Settings, Privacy and Security, and then you can select Allow Anyway. Open Anyway. There you go. So now it's playing anyway. Alright, so now it's all ready for us to listen, but we just have to start it up. Now starting it up is pretty simple. If we go to the chatbots, we can set awake to async, and we have the speech service recognizer, and the recognizer hasn't been set to actually start recognizing our text yet, but if we call this, then it will start recognizing straight away. So one more thing inside of the chatbot animator that I forgot to change is the animation being queued. As soon as you set these queue frames over here, we also want to say like, okay, we queued some new animations for you. So just be aware of that, and then it'll start going through all of the Blendshapes, and it'll play the audio, and we will have a conversation, I hope. But not before one more thing. We set the system prompt before, actually saying like, oh yeah, you're a chatbot, you're supposed to do this and this, and that's what we need to set before. So in these messages, we need at least one system message giving us the system prompt, and later on when it adds all of these messages, it has a list of the conversation that has been going on up until now. And this is the user keeps adding new information, and so that's like a list, like a history. But we do need a system message as the first message. So now that this is done, go back to Unity. Hello there, customer. What can I do for you today?
Good evening. I would like a table for one, please. I'll have the grilled salmon with vegetables. Can you ensure it's cooked precisely? And a glass of Sauvignon Blanc if you don't mind. Thank you.
Nah, dude, I don't think so.
That's not how you address a customer. I expect professionalism.
Alright, this guy's no fun at parties. I'll just leave him to it. If you want something more nice to talk to, just change this. Make him more funny or more interesting or whatever. But I think you get the point. You can actually have a conversation now with an avatar, an AI chatbot in Unity. And the interesting thing now is that because you made it in Azure, because you went through this whole flow, there's a lot that you can actually make better now. So think about like additions like inverse kinematics, so you keep like eye contact and it like turns towards you when you move around, like more animations when the chatbot is actually talking. You can set custom voices, so you can record your own voice, just like I scanned in my own face. I can actually do my own voice, which will be interesting. You can do fine-tune models, have like an actual database of knowledge that it can't like go out of, so you have like a more strict chatbot, so that will be an interesting one. There's also like keyword detection, so it can actually like trigger events, like actual stuff happening instead of the game based on keywords. And even if you think about AR or VR, you can do like the pass-through API. You can recognize like maybe a table in the room, and then it can talk about this table, or there's so many ways to go from here, and that's why like using this Azure is, yeah, it just opens up a lot of possibilities. Alright guys, that's it for today. I hope that you learned something and that you maybe can implement it yourself. Any questions or any comments, just leave them down below. There's also like URLs going through all of the documentation that we talked about, and the whole project is available on GitHub. So if you haven't been tagging along, just want to copy paste some stuff, go ahead. Alright, good luck, have fun, see you next time.